Hello everyone, I'm forecaster Jack Sillin here with a rundown of the severe weather setup for Wednesday, May 2nd, 2018. Going to start off, as always, with a look at our GOES East water vapor satellite imagery, which shows an upper level low that is continuing to move south and east. We saw this low over parts of Oregon on Sunday, over parts of Nevada yesterday. Now it is moving down towards the Las Vegas area. And it will continue to translate kind of to the east, southeast, throughout the day today. Out ahead of that upper level low, we're looking at, again, some persistent rising motion in the atmosphere, as we would expect ahead of an upper level low pressure system like this. So generally favorable conditions for thunderstorm development once again across the plains today. We can see a little bit of leftover activity from thunderstorms that developed yesterday evening. That is moving to the east near parts of Wisconsin and northern Illinois. These storms have weakened considerably from last night and do not pose a severe weather threat. The area that we're going to be watching again today is parts of Kansas down into Oklahoma, and then points to the north and east as those storms move northeast through the evening tonight. To take a look at some of the other features to watch near the surface, we're going to look at some of our dew point observations this morning. So this observed dew points at 6 a.m. Eastern, 5 a.m. Central, and we can see kind of a couple of boundaries that we're going to be watching today. So the first boundary to note is the dry line, currently stretching from parts of the Oklahoma Panhandle back through the Texas Panhandle and into eastern parts of New Mexico. That dry line is the boundary between very dry desert air and much warmer and moister Gulf air. So dew points in the 60s east of the dry line and in the teens west of the dry line. That very sharp moisture gradient will provide focus for severe thunderstorm development. The dry line is a feature that is known to retreat westward during the nighttime hours and move eastward during the daytime hours. So look for this feature to set up stretching somewhere from southern central Kansas down through the Oklahoma and Texas panhandles by the time we get to the afternoon today. Another boundary to note is this warm front slash stalled front frontal boundary stretching from near Hays, Kansas, up towards Omaha, Nebraska. You can see dew points to the north and west of that feature in the 40s and to the south and east of that feature in the 60s. So these are the two boundaries we're going to be watching, one oriented from northeast to southwest in this area and one oriented from north to south farther to the south here in parts of the Oklahoma and Texas panhandles. Looking at our ECMWF severe weather composite map, we can see both of these boundaries as well as plenty of instability to fuel thunderstorm activity. That's this shading once again today looking at CAPE or convective available potential energy. It's a measure of thunderstorm fuel. Values between 1,000 and 2,000 joules per kilogram. That is very favorable for severe weather. You can get plenty of storms with that amount of instability. That there will be no shortage of instability in this area that we're kind of watching from just south of Omaha through parts of central and eastern Kansas and into parts of central Oklahoma. So plenty of instability, no worries with that. The other features that the other ingredients rather that we need for severe weather development, wind shear, so change in wind speed and direction with height, we have that. So southeasterly winds here at the surface, not that strong, and then much stronger winds out of the west-southwest aloft. So a little bit of that changing wind speed and direction with height, wind shear, again, should not be a problem today. What we'll be looking for is the forcing mechanism, a kind of trigger, if you will, to unleash this potential energy and convert it to kinetic energy in the form of winds that can transport this warm, moist air up through the atmosphere where it cools and condenses, and that's how you get the thunderstorm clouds to actually form. So the trigger mechanisms, we're looking to the dry line in here that I talked about earlier, as well as that frontal boundary farther to the north. If you remember my video from yesterday, we looked at the orientation of the shear vector relative to these boundaries to see if we can get a sense of what kind of mode the storms are going to be in. So if they're going to be kind of discrete cells, or if they're going to be more linear in nature, or kind of organized cluster. I'll do the same thing really quick here. Shear vector is basically the sum of all the vectors that you see here, so the surface plus the low levels plus the mid levels plus the upper levels, and if you kind of average them out, if you will, you're going to get the shear vector, and that points today from southwest to northeast. That is parallel to the boundary that exists up here, that warm/stalled frontal boundary that we talked about earlier, kind of from Hayes up towards Omaha and Des Moines. So the shear vector is parallel to that boundary, so expect storms to be linear in nature up in this area. And then down here we're looking at that same southwest to northeast shear vector, but that's oriented at kind of a 45-degree angle to the dry line. So look for initially discrete cells to develop in here, but those cells will kind of coalesce into more linear storm modes compared to a shear vector that would be perpendicular to the dry line. That would favor a more continually discrete storm mode. So in terms of the threats we're looking for with these various storm modes, the lines of storms developing up here will pose a damaging wind threat primarily, along with large hail. Can't rule out a tornado, again, kind of along the leading edge of that line, but tornadoes will not be the primary threat up in this area. That will be damaging winds. Storms down here along the dry line will pose all severe weather threats, damaging winds, large hail, and the potential for tornadoes as well. Taking a look at our mid-level temperature maps, we can see why we might actually struggle to get storms to develop at all down here in the Oklahoma and Texas areas. And storms may struggle as they kind of move east off that dry line. So this is a map of mid-level temperatures at about 10,000 feet. And why is this important? Well, thunderstorms need a vertical temperature gradient to kind of fuel themselves. So the faster that the air cools with height, the better able storms are to develop and grow and produce severe weather. So there are always going to be warm temperatures near the surface of the earth. That's not a concern today. So the gradient is modulated by how fast the air cools with height, so how cold the air is in the mid to upper levels. So the colder the air is in the mid levels with the same warm surface temperatures, the stronger that gradient is going to be. So you can see we have some fairly cool mid-level temperatures ranging from about 5 to 7 degrees Celsius up here in Kansas, and then along the dry line itself a little bit warmer, 7 to 8 degrees Celsius. But as you move towards the Oklahoma City metro area, those mid-level temperatures spike up towards 10 degrees Celsius, so that's fairly warm. And what this will do is it'll act as a sort of cap on the atmosphere that will be hard for storms to punch through. And if storms aren't able to punch through the cap, they won't really amount to much in terms of severe weather. So the severe weather threat across parts of Oklahoma, especially central and eastern Oklahoma, is kind of conditional on these storms being able to break the cap and develop and kind of be able to tap into that moist, unstable boundary layer. So we'll be watching that. It's a little bit of a mitigating factor down here in parts of northern Texas and Oklahoma. Not so much a concern up in Kansas, where widespread severe thunderstorms are expected to develop, again, associated with those cooler mid-level temperatures. In terms of the general pattern, here's our upper level low, and this is going to be helping to create what's called forcing for ascent. So that's basically an environment in which rising motion is favored in the atmosphere, and we can actually see how this works by following this contour right here. This is the 5760 decameter, or that's meters, sorry, 576 decameter height contour. And watch as this retreats to the south and east from 2 o'clock to 5 o'clock. So that was well north and west of Wichita, now right over the Wichita area, and kind of holding there through the evening. So those height falls are helping to create a favorable background environment for severe thunderstorm activity. So that's the kind of final checkbox that we have, the overall background environment favorable for rising motion and severe thunderstorm development. Let's take a quick look at how storms may evolve this afternoon and evening. I'm going to take a look at the HRRR's kind of simulated radar. Again, don't use this for exact details. It will not be able to tell you which town a thunderstorm will move over this afternoon, but it does give you a good general idea of how storms will evolve throughout the day. So storms will initiate kind of in this area down here, southwestern Kansas, the Oklahoma Panhandle, along that dry line that we talked about earlier. Initially discrete, they will quickly coalesce into a line across parts of Kansas. We talked about that boundary parallel shear vector. And then more storms will develop later in the evening down farther to the south along that dry line, and those storms stand a better chance at remaining discrete while we get this line, this linear storm structure to develop farther to the north. Eventually, as we move later into the evening, all the storms will kind of coalesce into a line where damaging winds will be the main threat before the storms move farther to the north and east and weaken overnight. So that's a quick look at the pattern, what to expect from these storms, a little bit of the science behind why the forecast for these storms is what it is. Remember that even if a storm isn't producing large hail, damaging winds, or a tornado, it will remain dangerous due to lightning. So any of these storms will be producing plenty of lightning activity. So watch out for that, even if there isn't any severe weather ongoing with a particular cell at any given time. More severe thunderstorms will develop tomorrow. I will have another video on that tomorrow morning. Thanks for watching.